everyone, this is Dr. Lashik, and this lecture is going to go over a short activity that kind of wraps up everything that was learned in Chapter 8. The 4 questions below correspond to the little scenario in the red type above. And so let's go through these one at a time. The scenario is that a researcher conducted a study of 34 scientists. He reported a correlation between the amount of beer each scientist drank per year and the likelihood of that scientist publishing a scientific paper. The correlation was reported as R equals negative 0.55, P is less than 0.01. So question A, what does a negative correlation mean in this example? Is this relationship strong or weak? So what I'm getting at when I ask what does a negative correlation mean in this example, I'm looking for, in words, using the variables above, what relationship is there between beer drinking and publishing. All right, please take a few minutes to answer this question. All right, hopefully you've had a few minutes to answer question A. What does a negative correlation mean in this example, and is this relationship strong or weak? So let's go over the first one. What does a negative correlation mean in this example? It means the more beer a scientist drinks, the less likely they are to publish. As one is high, the other is low. And we could say the opposite is true as well. So scientists are more likely to publish the less beer they drink. Is this relationship strong or weak? This is strong, and we're basing this off of Cohen's values, Cohen's cutoff. Any R value near 0.5 is considered strong, whether or not it is negative or positive. So negative 0.55 is considered a strong correlation. All right, B, what does P is less than 0.01 mean in this result? Please take a minute to answer this question. All right, hopefully you've had a few minutes to answer question B. What does P is less than 0.01 mean in this result? P is less than 0.01 means that there is a 1% probability that the results were due to chance. This means that it is very, very unlikely, so less than 1% chance, that everything was just a big mistake. And that those are odds that scientists like to base their conclusions off of. Usually the cutoff again is 0.05 or 0.01, so very, very small odds that everything just happened to be due to chance. So we would consider this result, because P is less than 0.01, statistically significant. All right, C, what might happen to this correlation if you added one person in the sample who drank much more beer than the other scientists excuse me, and also published far fewer papers than the other scientists? Please take a second to answer question C. Hopefully you've had a minute to answer question C. What might happen to this correlation if you added one person in the sample who drank much more beer than the other scientists and also published far fewer papers than other scientists? So question C is asking about an outlier. What happens when an outlier is added into your sample? And an outlier in either direction is problematic. In this case, this outlier would cause our R value to be inflated. And that's what outliers do. They either inflate your R value or deflate your R value. And either way, it's problematic, because what we're trying to do is get the most accurate R value possible. And so in this case, it would inflate our R value because this person over-exemplifies the relationship. A lot more beer, a lot fewer papers. And if it was opposite, where they had a lot more beer but a lot of papers, that would deflate our R value. It would make it seem it was less related than it really is. All right, the last question. A popular press reports about this article, and it was headlined, "Suds Seem to Skew Scientific Success." This headline is a causal claim. So the question is asking, is such a causal claim justified? And assess using the causal rules. So just as a reminder, the causal rules are covariance, temporal precedence, and internal validity. So assess this scenario based on those 3 rules, and write down why they meet that criteria or do not meet that criteria. Please take a minute to answer those questions. Hopefully you've had a few minutes to answer question D. A popular press report about this article was headlined, "Suds Seem to Skew Scientific Success. Is such a causal claim justified?" And assess using the causal rules. So the answer to is a causal claim justified is no. And again, association claims meet the first rule of causality. Number one is covariance, and covariance is just a fancy way of saying correlated. And since this is an association claim, yes, variable A is correlated to variable B, as they've discovered with their R value and P value. And so again, it's just simply asking, is variable A correlated to variable B? So yes, it meets the first rule of causality, covariance. Number two, temporal precedence. It does not meet temporal precedence. Remember, temporal precedence suggests that because we've manipulated variable A, it has changed variable B. Temporal precedence ensures that the manipulation has occurred before the measurement of variable B. And we have no way to know that, because in this scenario, and with all association claims, we are only measuring variable A and B. We are doing absolutely no manipulation whatsoever. And so we have no idea what came first. It could be that more beer drinking caused fewer publications. Maybe it was that they were busy drinking beer, they had less productivity. Or it could be that because they weren't getting things published, it caused them to drink more beer. And we have no idea which direction that relationship will go, or if there's some third variable that we haven't even measured, because we did no manipulation whatsoever. We're just measuring two variables after they've happened, after the fact. And so temporal precedence can't even be assessed with an association claim. So it does not meet the criteria for temporal precedence. The third criteria is internal validity, and that again asks if there's any other possible alternative explanations for the results. And there are loads of alternative explanations for these results. Again, because we didn't manipulate anything, we didn't control the conditions. There was no experimental process in any way. It was just asking scientists how much beer they drink and how many publications they've produced. So again, since there was no control, there's loads of other possibilities that could be responsible for these results. For instance, maybe there's this third variable that causes both beer drinking and low publication rates. Perhaps depression might have been that variable. Highly depressed people might drink more beer and also not feel up to doing the work it takes to get publications. So there's loads of other possible variable C's that we just didn't measure. And again, we would know about the strength of our internal validity if we had manipulated one variable, controlled all other variables, and then measured variable B. But since there was no manipulation and control, we cannot make that claim. So no, it does not meet the criteria for a causal claim. It is purely an association claim. All right, if you have any questions about this, please don't hesitate to email me.